Hello, I'm Javier. In this video, I will explain the topics covered in the problem situation and provide an explanation of how we select the challenge. In the first part of the problem situation, we focus on predicting the sales price of a specific car, which was a Camaro, to estimate the future price. Initially, we create a scatter plot to visualize the relationship between the Camaro's age and its sales price. So from the scatter plot, we can see that each point represents a car, obviously. The x-axis shows the age and the y-axis shows the price. It's evident that this model has a negative trend, meaning that as the age increases, the price decreases. Visually, the points approximate a straight line, indicating that the model is indeed reliable. When calculated using Minitab, the correlation coefficient confirms this, with a high negative value of minus 0.872, making the model very reliable. And in another part of this activity, we were asked to create a graph that relates millage in miles x-axis to price y-axis. This graph also shows a negative trend, as you can see in the screen, indicated that the more miles a car has, the more its value depreciates. This is suitable because it presents a linear pattern, with a correlation coefficient of minus 0.857. We also, in the other hand, we create a linear regression model to predict the Camaro's price. This required a multiple linear regression model considering both age and millage to predict the price. The resulting equation shows that if the car's age increases, the sales price decreases by 22,744 per year. Similarly, for each mile driving, the price reduces by $900. This regression also indicates that the p-value of less than 0.05, suggesting that the model is significant and useful for price prediction, as you can see there in the screen of this presentation. To conclude this first part of the problem situation, we develop a multiple regression model incorporating all variables: age, millage, one owner condition, excellent condition, and average condition. This regression analysis include both continuous and categorical variables. Unlike the previous analysis that we did, which only considered continuous variables, in these, categorical variables represents by 0 and 1 values cannot be mixed with continuous variable in the same equation, making the resulting model, as you can see here, unsuitable for estimating the sales price. So this cannot be useful for us to estimate the pricing. To verify the significance of the coefficients of these variables, p-values are used. If there are less than 0.05, the coefficients are considered statistically significant. In this case, the coefficients are significant. In conclusion, while the multiple linear regression model with age and mile age fits data well, that is another scatter plot that I did, incorporating our variables required a careful consideration of their types and significance. We need to ensure that the model remains interpretable and accurate. Moving on the second part of the problem situation, the used car agency wants to predict the number of Camaros cars that will be sold next year. This is crucial to ensure the supply, as these cars are highly valued on the market. They are so expensive. We will use various forecasting methods to estimate next year's sales. In this part, we use all methods we learned in class for calculating forecasts, including moving average, simple exponential smoothing, trend analysis, multiplicative winter, and winter additive. And this winter method with variable values. Here on in his page, you can see all the methods we employed. Um, However, all methods expect winters cannot be used to calculate seasonality. For this part of the situation, we were asked to choose the best method for determining predictions. By using the MAP value, we can select the best method, which is winter multiplicative method with level, trend, and seasonality values of 0.4. Here in the screen, this is all the methods that we did and the all Minitab results. And here's the thing that I want to explain you. So the method that is the best is the multiplicative winter with we as I said, making this method making it the most suitable for predicting quaternary sales for next year. Now, what is a winter's multiplicative method? Okay, let me explain this. Explain. It's an exponential smoothing technique used for forecasting data with trends and seasonality. In a sense, this method adjusts both the trend and the seasonality variations in the data, providing more accurate predictions compared to simpler methods that are like average, moving average, and the other ones. Choosing the most suitable method depends on having the lowest MAP, which stands for mean absolute percentage error. This means that accuracy of a forecasting model by calculating the average error in percentage terms make it easier to interpret the model precision. So if this is less, the less it will be the best method that we can use. This concludes that it's all for my explanation, the problem situation. Thank you very much for see it and see you.